I'm Jeffrey and this is the datum of our product. Imagine this, in 5-minute time, you can order a coffee, check your email, politely glance at the cafe goers, receive your ordered coffee and return to where you left your locked bike, which was stolen 4 minutes ago while you were gone. You must start to panic because even though you left your bicycle locked up, it is just not reliable enough. And that is the moment you start to wonder if there's even a solution to prevent your bike from getting stolen again. A bicycle is a small human-powered land vehicle with a seat, 2 wheels and 2 pedals. The name comes from 2 words, bi which mean 2 and cycle which mean wheel. Bicycles are convenient and popular transportation for over a decade. People like to ride them to work, travel and exercise, but these features doesn't help in providing safety to the bike. With nearly 400,000 bicycles stolen each year, it turns out that you need more than just a good lock to keep your bike safe. What you need is security.
Assalamualaikum and hello everyone, I'm Khairul Hariz and I'll be presenting on the key features and the composition chart of my group project, the Smart Bike. First of all, the key features to our Smart Bike, we have 5 of them, which is the first one being the power source, and then the sensor, moving on to the alarm deactivator, and the GPS, and we also have the alarm itself. Okay, for the power source, we have 2 types of power source, which is the dynamo and the battery. For the sensor, we have 3 of them, which is the pressure sensor, the touch sensor, and the wires in the seat. For the deactivator, for the alarm, we have 3 ways to deactivate, which is using a remote button, using a biometric sensor, or even using a PIN number. For the GPS, we have decided for 3 locations to put it on, which is first being under the seat, on the handle, and in the wire lock. For the alarm, we have no specific specifications, and we have decided it is a normal alarm which will go off on the sensor or deactivate using the deactivator. Moving on to our decomposition chart, we have created 2 separate ones. The first one being separating the features according to their categories and types as shown on the screen. And then the second decomposition chart, we have separated it into our choices of solutions, which will be elaborated in the next part of this presentation. That is all from me, Khairul Hariz. Thank you.
Hi, my name is Shawn and I'll be talking about the morphology chart and its plausible concepts. So to solve the problem of the lack of security of the bicycle, we came up with 3 solutions. Each solution has an alarm which will be triggered when the robber tries to steal the bike. The differences of these solutions are the way that the alarm is triggered, the power source of the circuit, the way the alarm is deactivated, and the placement of the GPS. So for the first solution, we came up with a solution that's centered around the seat of the bicycle. So as you can see, we placed a piezo sensor on the seat. So whenever someone unwanted sits on the seat of the bicycle, the piezo sensor is stimulated, thus sending a signal directly to the alarm, which will cause it to sound. The tracking device itself is placed right under the seat so that it is near with the piezo sensor and the alarm, so that the whole circuit can be connected to the dynamo in the wheel. In this concept, the way that the alarm is deactivated is with a fingerprint sensor that is placed under the seat. So whenever the user wants to use his own bicycle, he can place his finger on the fingerprint sensor, which then will deactivate the alarm itself. Moving on to the next solution. For the next concept, we centered around the handle of the bicycle, because to be honest, who would try to steal a bicycle without touching the handles itself? So to utilize this, we placed touch sensors on the handles itself. So whenever someone unwanted tries to touch the handles of the bicycle without deactivating the alarm beforehand, the alarm will be sound, thus notifying the bicycle owner of an unwanted guest. The GPS for this solution is placed right next to the touch sensors, and it is powered through a dynamo placed on the wheel. The way that the alarm is deactivated for this concept is through a remote button, as you can see here. So you can say that this concept somewhat works the same as a car alarm system. And for the last concept, we center around the wire lock for the bicycle. So whenever someone tries to steal a bicycle that is locked with a wire lock, they would try to cut the wire. So whenever someone tries to cut the wire for this one, it'll cut the circuit in the wire lock itself, thus causing the alarm to sound. The tracking device for this concept is placed right here next to the pin lock, which is used to deactivate the alarm, and the battery holder, which holds the battery that powers the whole concept. That is all for the morphology chart and the plausible concepts. Thank you.
Hello there, my name is Zachary, and today I'll be presenting about our product evaluation. Our product, the Smart Bike. There are 6 criteria, which are trackability, ease of use, cost of alarm system, power source, alarm, and security. We have 3 different concepts. So in concept 1 and concept 2, they get a plus in trackability, while concept 3 gets same. Concept 1 and concept 2 gets plus in trackability since the GPS would be installed directly inside the Smart Bike. While in concept 3, it would be same because the GPS would be installed inside the pin wire lock. So if the user weren't to lock the bicycle using the pin wire lock, the bicycle wouldn't be trackable and would still be the same as a normal bike. Second, ease of use. Concept 1 and concept 2 still get plus, but concept 3 still gets same. Concept 1 and concept 2 uses either remote control buttons like a car, or concept 2 gets biometric sensors, which would need just a touch. In concept 3, we would still be using a pin wire lock, so it would be the same as a user buying a normal pin wire lock and locking their bicycle using it. Thirdly, cost of alarm system. Concept 2 gets a minus in this because it uses biometrics, and biometrics aren't cheap. Concept 1 and concept 3 uses either a remote control or a pin wire lock. This would be relatively cheaper. Power source. Concept 1 and concept 2 get a plus. This is because concept 1 and concept 2 would recharge a rechargeable battery using dynamos. In concept 3, it would directly use batteries. The user would have to either recharge it or replace it when its time comes. This would then be less of a convenience for the user. Fifth, the alarm. All the concepts get a plus in alarm since the alarm would always be installed in the bicycle. Lastly, security. Concept 1 and concept 2 again gets a plus, but concept 3 would be the same. This is because in concept 3, if the user weren't to put the lock on their bike, then their bike wouldn't be able to sense if there was a thief, or it wouldn't be able to track the bicycle since the GPS wouldn't be on the bicycle. Concept 1 and concept 2 has guaranteed security since its alarm system would always be in power, as the dynamo would always recharge the rechargeable battery. It has biometrics or a remote control, and the GPS would always be inside the bicycle. Therefore, based on this evaluation matrix, concept 1 has 6 plus, 0 minuses and sames. Concept 2 has 5 pluses but 1 minus. Its same is 0. Concept 3 has 3 sames, 1 minus and 2 pluses. Therefore, we have chosen concept 1. That is all that I'll be presenting. I'll be signing off now. Thank you.
Hello everyone, my name is Rugag and I'll be explaining the final design for our project. First of all, the final design consists of piezo sensor, alarm, tracking device, dynamo, and key to disable and enable the alarm. The piezo sensor sends if someone sits on the bike and sends signal to the alarm. If the alarm is not disabled, then it will be triggered and alert everyone surrounding the bike and also the user. The GPS is to locate the location of the bicycle. The dynamo is to power the rechargeable battery inside the alarm so that all the device can be kept alive. The key is used to disable the alarm using radio wave. The alarm consists of buzzer, rechargeable battery, and a receiver. The cost of this whole project is about 1,065 ringgit. The peso sensor is about 150 ringgit. The tracking device is about 300 ringgit. The dynamo costs about 150 ringgit. The alarm costs about 60 ringgit. 10 ringgit for a buzzer and 50 ringgit for the rechargeable battery. The receiver and the key implementation costs about 75 ringgit. The bike costs about 330 ringgit to produce. The bike is manufactured by us because it is not easy to install all these devices inside the bicycle. So it will be easier if it is installed when it is manufactured from the factory itself. That's all for the final design.